So I had to come to a different area here at the college. I don't. The whole point was to like record in the locations, in like these specific locations. That was the point. But um, I'm trying not to be loud here. So I thought I would just explain how to pretty much like solve anything in like mathematics, whether it's like expressions or equations, equalities, like anything, pretty much anything. So, and you can do it quick. All you have to do is you just break everything down, you solve it part by part. So what I've done is an example of the Ramanujan-Sato series right here. So series number 1, and then I have a Ramanujan dash 1 1914 right here. So these are like two completely different like series of steps that you do. So this is the output for the Ramanujan dash 1 1914. So when you do this right here, or when you do this one over here, you end up with this computation, right? You end up with this pi. So it says 1 whole pi equals 3.14159265358, etc., right? And it'll keep going, you know what I mean? I'm gonna hold the camera up because I can't get a good angle, but so all you do is you just it's really easy. You apply PEMDAS, and PEMDAS is parentheses, exponents, multiplication, and then division, and then addition, and then subtraction as it occurs, right, on the line. Okay, so if you like approach it like if you approach it like this, then what you do is you go and you solve each part little by little, and you break it down to like the decimal numbers or the whole numbers, right? So you do all of the operations. So this is saying like the square root of 2. So what's the square root of 2? It's going to be 1.41421356237, right? So if you multiply 1.41421356237 times itself, you're going to end up with 2. So and then so this is the Ramanujan-Sato. This is how you solve it. Okay, so I'm just using this as an example on how to solve pretty much anything in mathematics by using this. Okay, so it's saying 1 whole pi equals the square root of 2 over 99 squared, right? So that's 99 times 99. And then you have like an infinite summation here, right? So the k is the variable, and it starts at 0. So every time you do this operation, once you're done with this, you then make k into a 1. And then when you're done with 1, you make k into a 2. And then k into a 3. And then it keeps going on infinitely. And this is how you get the next decimal place of pi. So we have like the decimal places of pi up here according to the Ramanujan-1 1914, right? Technically, this is an algorithm. It's not a formula, because this is a series of steps that you follow to get the next decimal place of pi. Okay, and you're gonna be right. It's correct every single time it functions, right? Every time it like executes, almost like a computer. Okay, so what you do is, then over here you got 4k. So you've got 4k, and then the exclamation for product, and then k product 4th exponent, right? And then over here you've got 26390k plus 11